Let us look at this NEET question, 2019 question from the chapter of chemical bonding and molecular structure. Which one of the following diatomic molecular species has only pi bonds according to molecular orbital theory? N2, C2, Be2, O2. These are the species given, diatomic species given to us. Now let us write their molecular orbital configuration. Let us write them like this. So N2 means 14 electrons are there. One nitrogen is having 7 electrons. So two of them, 14 electrons. So sigma 1s2, sigma anti-bonding 1s2, sigma 2s2, sigma anti-bonding 2s2, then pi 2px2, pi 2py2, and sigma 2pz2. This is how the electrons are placed in the molecular orbitals. So from this we need to calculate the bond order. That means bond order is equal to number of bonding electrons, that is number of electrons in the bonding orbitals minus number of anti-bonding electrons in the anti-bonding orbitals divided by 2. Now let us count the number of electrons in the bonding orbitals. 2 plus 2, 4, 6, 8, 10. 10 electrons in the bonding molecular orbital. The anti-bonding orbitals, that is the ones with these asterisk. 2 plus 2, 4. So 10 minus 4 by 2, that is equal to 3. So there are 3 bonds or covalent bonds between these nitrogen atoms. Now here you can see there are 4 electrons, 2 plus 2, 4 electrons in the pi bonding molecular orbital and 2 electrons in the sigma molecular bonding orbital. So 4 electrons will give you 2 pi bonds, and these 2 electrons in the sigma molecular orbital will give you 1 sigma bond. So here you have pi bonds and a sigma bond, 2 pi bonds and a sigma bond. So this is not what we want. We want the diatomic molecular species which has only pi bonds. So that is not the answer. Let us look at C2. It has 12 electrons, each carbon having 6 electrons. So if we place them in the molecular orbitals, sigma 1s2, sigma, that is, these are bonding, these are anti-bonding, sigma anti-bonding 1s2, sigma 2s2, sigma anti-bonding 2s2, and pi 2px2 and pi 2py2. And sigma 2pz is 0. There are no electrons in the sigma orbital. So here we have only pi bonding electrons or orbitals. Let us look at the bond order. Bonding electrons are 2 plus 2, 4 plus 2, 6 plus 2, 8. 8 minus anti-bonding electrons are 2 plus 2, 4. 8 minus 4 by 2 is 2. So there are 2 bonds between these carbon atoms, and both of them are pi bonds according to molecular orbital theory. Both these bonds are pi bonds, because here also you have bonding and anti-bonding electrons, but they cancel out. Sigma 1s2, 2 electrons in here, and here in the anti-bonding orbital also 2. So they cancel out like that. And here there are no electrons. So only pi bonds are there in C2. What about beryllium Be2? There are altogether 8 electrons, 4 each. So sigma 1s2, sigma anti-bonding 1s2, sigma 2s2 and sigma anti-bonding 2s2. Here you can see number of bonding electrons are 2 plus 2, 4. 4 minus anti-bonding electrons are 4. So bonding are 4, anti-bonding also 4. So 4 minus 4, 0. So bond order is 0. So according to molecular orbital theory, this molecule Be2 does not exist. So this is also not the answer. We have found one, that is C2, where there are only pi bonds. We'll just mark them. That is option B, C2, having only pi bonds. Now let us look at oxygen also. O2, 16 electrons. If we place them in the bonding and anti-bonding orbitals like this, we can see that here in the case of oxygen, the filling up of the molecular orbitals are a little different. That is, sigma 2pz is coming before these pi bonds, pi molecular orbitals, due to energy concentrations or mixing of molecular orbitals. This 2pz is getting filled up first, and then only pi bonds, pi molecular orbitals come. So if we look at the bond order, you can see 2 plus 2, 4, 6, 8, 10. 10 minus, now antibonding, 2 plus 2, 4, plus 1, 5, plus 1, 6. So 2 is the bond order here also. And you have sigma bonds here, because 2 electrons are here. And pi also are involved. So you have sigma and pi. So between two oxygen atoms, you have 2 bonds. So one will be a sigma bond and the other will be a pi bond. Because here in the anti-bonding orbitals, pi anti-bonding, you have 1 electron each. So in effect, there is the effect of only 1 electrons from this. So 1 pi and 1 sigma. Now, so the answer to our question is option B. So just remember that while filling up the electrons from till nitrogen, elements till nitrogen, it is the pi 2p orbitals which come first. After that, after nitrogen, that is oxygen comes after nitrogen, it is the 2p sigma 2pz which comes first, and then only pi 2px and pi 2px and pi 2py come. So option B is the correct choice.